right? This question can be found in TYS 2006, question 9. So A, part 1. Name the type of chemical bond found in a molecule of carbon dioxide, right? So you need to have a thinking process. So firstly, okay, you need to know what is the chemical formula of carbon dioxide, right? Okay, so you know that one molecule of carbon dioxide contains one carbon atom and two oxygen atoms, right? Recall that carbon and oxygen, they are non-metals, right? And the bonding that occur between non-metal atoms should be covalent bonding. So to answer the question, the type of chemical bond found in a molecule of carbon dioxide is covalent bond. A, part 2, right? You need to draw a dot and cross diagram to show the arrangement of electrons in a carbon dioxide molecule. Only the outer electron shells need to be shown. So you have to read the question very carefully. Again, this is your thinking process. Okay, please show only the valence electrons. We have already established previously, okay, that the type of bonding is covalent bonding. So for covalent bonding, all right, there is a sharing of valence electron. So your dot and cross diagram should look like this, because sharing of electrons, so the atoms must have some form of overlap, okay, so you can actually show the sharing of electrons. So the electronic configuration of carbon atom is 2.4, right? So it means that it has 4 valence electrons, and this carbon atom requires 4 more valence electrons in order to achieve the noble gas configuration. And therefore, if you need 4 more electrons, you have to share 4 electrons. Okay? On the other hand, the electronic configuration of oxygen atom is 2.6, right? Which means to say an oxygen atom has 6 valence electrons. So it requires 2 more valence electrons in order to achieve the noble gas configuration. If you need 2 more, you need to share 2 valence electrons. Okay, so let's try to draw the dot and cross diagram. All right, we'll start with the carbon atom, right? Then you will draw the oxygen atom. There should be 2. Okay, then let's start with the oxygen atom first, right? So you have 6 valence electron and it shares 2 valence electron. So I'm going to put 2 electrons here, right? So this is sharing of 2. So you need to put 4 more valence electron, because an oxygen atom has 6 valence electron. And we will do the same for the other oxygen atom. Okay, so we use the cross to represent the electrons for oxygen atoms. So for carbon atom, we need to use a dot. Remember, carbon atom shares 4 valence electron. So 1, 2, 3, 4, right? So carbon shares 4 valence electron And also carbon has 4 valence electrons, so 1, 2, 3, 4. So this is the dot and cross diagram for carbon dioxide. Alright, so in order to check your answer, you need to count the total number of electrons. So for this particular atom, you have 1, 2, 3, 4, 5, 6, 7, 8. So you have the noble gas configuration. For this carbon atom, 1, 2, 3, 4, 5, 6, 7, 8. So you also have the noble gas configuration. And the same goes for this oxygen atom, right? Okay, for part B, substances with the chemical bond found in carbon dioxide normally have a relatively low boiling point. Explain why. Again, you need to have your thinking process, alright? So, the chemical bond in this particular question refers to covalent bond. Okay, so substances with covalent bond, they have relatively low boiling point. So these substances are covalent compounds, okay, with simple molecular structures. Okay, and we know that these substances contain molecules which are held together by weak intermolecular forces of attraction. And this explains why the boiling point is relatively low. Okay, so what do I mean by this? So if you can remember, okay, imagine this is one molecule, okay, this is another molecule, okay, and we have the third molecule. Okay, so in this particular molecule, okay, there is sharing of valence electron, okay, and this bond here is known as a covalent bond. Same goes for this bond here. This bond is also known as a covalent bond. Same goes for the bond over here, right? Then there is also the intermolecular forces of attraction. Okay, for example, so this is the intermolecular forces of attraction, right? So in actual fact, the covalent bonds, they are not overcome during boiling, but the intermolecular forces of attraction, they are overcome during boiling. Okay, and the intermolecular forces of attraction, okay, they are generally weaker. Therefore, the boiling point will be lower. Okay, so during boiling, right, we actually break or we overcome the weak intermolecular forces of attraction. But the covalent bonds, they are not overcome. Okay, they remain there. Right. So, let me reveal the answer. Okay, you need to mention that carbon dioxide is a covalent compound. It's important, with a simple molecular structure, right? And the molecules of carbon dioxide, they are held together by weak intermolecular forces of attraction. So the molecules, they are held together by weak intermolecular forces of attraction, and you need only a small amount of energy, okay, to overcome, right, to overcome the weak intermolecular forces. Therefore, simple covalent substances usually have a relatively low boiling point.